Imagine this. You updated a student's major name in one row in a table, but forgot to change it in other three. Now your data is inconsistent, and worse, your reports are wrong. This happens when your table has transitive dependencies. In this video, you'll learn how the third normal form can be used to address issues like this in your database design, and why it matters in real-world situations. Let's get started. A few words on normal forms first, in case if you need to refresh your memory. So what are normal forms? Normal forms are the rules that can guide you break down messy big tables into smaller and more organized tables. There are multiple normal forms, including the first normal form, second normal form, and the third one, and it can go on and on. Each normal form addresses specific types of problems. And normal forms build on each other with increasingly strict requirements. They form a nested containment relationship. To achieve any normal form, you must first satisfy all the lower levels. For example, for a table to satisfy the requirements of the third normal form, it has to satisfy all the requirements of the first normal form and the second normal form in the first place. The first normal form checks the fundamental stuff, such as whether a table has a primary key or multi-valued columns and whether each column has a data type. The second normal form is about dealing with partial dependencies of any keys. If you need to learn more about the first normal form or the second normal form, you can find the links of videos dedicated to the two normal forms in the description. In this video, we will focus on the problems that the third normal form aims to address. Remember, we are on our journey to understand a simplified version of the third normal form for now. Based on the definition of the simplified version, if a table is in the third normal form, then no non-key columns in this table can be transitively dependent on the primary key. There are two terms here that require some clarification. First, by non-key column, I mean the columns that are not the primary key or a part of the primary key in case if the primary key is a composite one that has more than one columns. Second, transitively dependent. Before we get to this term, let's make sure that we are on the same page in terms of what a dependency means first. In the context of columns of a table, functional dependency means that if you know the value of column A, you can always figure out the value of column B every time without exception. In such a case, you can say that column A functionally determines column B. Or you can also say that column B functionally depends on column A. For example, think about a table representing employees, and the table has only two columns, employee ID and employee name. Employee ID is the primary key of the table. Given a value of the employee ID, you can always figure out the corresponding employee name. We can see that employee ID functionally determines the employee name, and express this dependency relationship using an arrow that goes from employee ID to employee name. You may also see the same relationship expressed as employee name functionally depends on employee ID. Okay? Now to transitive dependency. It means a non-key column is functionally dependent on another non-key column, which in turn is functionally dependent on a key in the table. Now you know what transitive dependency is. Let's go back to the issues the third normal form aims to address. I mean the simplified version of the third normal form. If a table contains transitive dependency, it means trouble. It means that the table violates the third normal form and needs to be fixed. For example, think about a table representing employees of a company. It has four columns and uses a surrogate key, employee ID, as the primary key. The table contains two functional dependencies. The first is about the primary key functionally determining two other columns, including employee name and department ID. The second functional dependency is about department ID functionally determining department name. Based on such information, You can tell that there's a transitive dependency, which department name is functionally determined by department ID, which in turn is determined by employee ID. Before we talk about how to fix such an issue, I want you to know what issues transitive dependencies may cause. Think about when the table is populated with data. There would be a lot of redundancies since many employees will belong to the same department, which means that the same department ID values and department name values are repeated in many different rows. Beyond that, if you ever try to update a department name, you will need to make sure to update every row that contains the old value. If you ever forget to do that, there will be data inconsistency. In short, it will cause data redundancy and all kinds of update and delete anomalies. Now you know what the problem is, let's talk about how to fix the issue. You need to move the columns in the transitive dependencies to a different table, and the determinant will become the primary key in the new table. In this example, that's the department table. Additionally, you will keep all the columns that are directly dependent on the primary key in the old table. So the employee table will have 3 columns after the update. Notice that the department ID will show up in both tables in our fix. That's because it perfectly meets the 2 conditions. It's directly dependent on the primary key in the employee table, as well as it was involved in the transitive dependency. That's why it ended up showing in both of the 2 tables after we fixed this design flaw. Beyond a bad design inherent to a single table, a violation of the third normal form can also be caused by 3 tables in a circular relationship. For example, think about 3 tables from a database supporting an online store. So the tables are user, payment methods, and purchase. The user table represents users of the store. Payment methods represent users' different payment methods that are used for ordering stuff online. And the purchase table represents the order records from users. Between each pair of the 2 tables, it's a one-to-many relationship. However, that also leads to putting 2 foreign keys, payment ID and email, into the purchase table. Payment ID is the primary key in the payment method table. Email is the primary key in the user table. However, we know that the primary key in a table functionally determines all other non-key columns. From the payment method table, we can learn that payment ID determines email. From the purchase table, we have something similar, which is the purchase ID functionally determines payment ID. If we put these 2 relationships together and focus your attention on the purchase table, we will have a transitive dependency like this, in which purchase ID functionally determines payment ID and payment ID also determines email. So, by definition, that's a transitive dependency, even though the purchase ID can also directly determine email in the same table. How do you fix such an issue? When 3 tables present themselves in such a circular relationship, all you need to do is to remove one of the 3 relationships so that the table that suffers from transitive dependency issues will no longer need to. In this case, you can remove the relationship between user and purchase. In other words, you need to remove the foreign key email from the purchase table as well. The fixed relationship will look like this. With such a fix, you may wonder how the purchase table can be connected to user if there's ever such a need. They can still go through the payment method table. That's everything about the simplified version of the third normal form. Let's move to look at the full version and explore the fine-grained difference between the simplified version and the full version next. In the simplified version, we laser focused on the transitive dependency on the primary key. But the full version is actually a bit broader. Beyond the primary key, it also cares about any candidate keys that are involved in transitive dependencies. The full version of the third normal form states that no non-key columns are transitively dependent on any candidate key. In other words, in a table that doesn't violate the full version of the third normal form, you shouldn't be able to find any non-key column that is transitively dependent on any keys. Now, you know the definition of the full version of the third normal form. Let's compare the simplified version to this full version, so that you can have a robust understanding of the third normal form and appreciate the fine-grained difference between the two versions. Let's look at the enrollment project table, which represents student enrollment at a university. The table uses email address as the primary key. Beyond that, it has three more columns: student ID, name, and GPA. In addition to the primary key, the table has another candidate key, the student ID. The table has three functional dependencies. The first one is about the primary key functionally determining two columns, including student ID and GPA. The second is about student ID as the candidate key functionally determining name and the GPA. The third is about the name column functionally determining the GPA column. In case if you think the design of the table is ridiculous, it is indeed ridiculous. However, a reasonable and authentic design that can help differentiate the simplified and the full versions of the third normal form almost doesn't exist. So bear with me on this and let's continue. Does this table violate the criteria of the simplified version of the third normal form? You can ask yourself, do you see any transitive dependency on the primary key? Nope. That said, it's perfectly valid in the eyes of the simplified version of the third normal form. However, does the table violate the criteria of the full version of the third normal form? Student ID as a candidate key functionally determines name, and name in turn functionally determines GPA. That said, you do have a transitive dependency on a candidate key. So the table is not in the third normal form. How do you fix this issue? In the same way as you fix a violation to the simplified version of the third normal form. You need to move the columns in the transitive dependencies to a different table, and the determinant will become the primary key in the new table. In this example, that's the name GPA table. Additionally, you will keep all the columns that are directly dependent on the primary key and any other candidate keys in the old table. So the enrollment table will have three columns after the fix. Notice that the name column will show up in both tables. That's because it perfectly fits both conditions. I mean, it's directly dependent on the primary key as well as was involved in the transitive dependency. That's why it shows up in both tables after we fix this design flaw. I know that the name GPA table looks really ridiculous in real world. You would never put such two columns as one table, but let's just focus on the things at the theoretical level. After all, an example that can do this job, differentiating the two versions, is very elusive. In this video, we covered a simplified and a full version of the third normal form and how to use them to guide your normalization of database designs. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deeper into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.